learners, I am Professor Munish Kumar Bharadwaj, and today I will discuss with you risk assessment for scaffolding part 2. Part 1 we have already covered. Now in this part we will cover the process of risk assessment, that how risk assessment is done, what is the procedure, and how the risk matrix is prepared. The learning outcomes for this lecture will be that after going through this lecture, you should be able to define the process or explain the process of risk assessment, and also you should be able to prepare the risk matrix. Now, let us move to risk assessment. Conducting a risk assessment in scaffolding works is a systematic process that helps identify and mitigate potential hazards to ensure the safety of workers. Here, let us see the practical steps to perform a risk assessment for scaffolding. The first step in this process is define the scope of work. Clearly outline the scope of the scaffolding work, including the purpose, location, and duration of the project. Understanding the specific task to be performed is crucial. Second step is assemble a team. Form a team of individuals with expertise in scaffolding, safety, and relevant aspects of the project, including designers, scaffold erectors, and safety professionals. Then third step is identify hazards. Walk through the work site to identify potential hazards related to scaffolding. This includes assessing the environment, the structure itself, and any specific risk related to the task at hand. Common hazards include falls, structural instability, weather conditions, electrical hazards, and falling objects. Then the next thing is analyze and estimate risk. Risk is the determination of probability and severity of the credible accident or event sequences in order to determine magnitude and to prioritize, identify hazards. It can be done by qualitative, quantitative, or semi-qualitative method. Number 4 is identify persons at risk. Determine who may be exposed to these hazards, such as workers, site visitors, or the general public. The fifth step is assess risks. Evaluate the likelihood and severity of each identified hazard. Use a risk matrix to categorize the risk based on these assessments. Sixth step is implement control measures. Develop and prioritize control measures to mitigate or eliminate risks. These measures can include proper training and certification for scaffold erection and use, regular inspections and maintenance of scaffolding, use of appropriate personal protective equipment, that is called PPE, then guardrails and the toe boards, then fall arrest systems. Secure anchorage points for all protection systems. Weather monitoring and appropriate measures for adverse conditions, and safe access and egress. Seventh step is document the risk assessment. Maintain a comprehensive record of the risk assessment, including identified hazards, assessed risks, control measures, responsible individuals, and dates of assessment and reviews. Next step is review and update. Regularly review and update the risk assessment as the project progresses and circumstances change. New hazards may arise and control measures may need adjustment. Ninth step is communicate and train. Ensure that all personnel involved in scaffolding work are informed about identified risks and control measures. Provide necessary training and ensure that workers understand and follow safety procedures. Step 10 is compliance with regulations. Familiarize yourself with and adhere to local and national regulations and industry standards related to scaffolding and construction safety. Compliance with these standards is crucial for risk reduction. Step 11 is emergency response planning. Develop an emergency response plan that includes procedures for addressing accidents, falls, and other unforeseen events. Make sure all workers know the emergency protocols. Step 12 is ongoing monitoring. Continuously monitor the work site to ensure that the risk assessment remains accurate and effective. Encourage workers to report new hazards or unsafe conditions. Step 13 is evaluate the effectiveness. Periodically assess the effectiveness of the control measures and make adjustments as necessary. Step 14 is record keeping. Maintain detailed records of inspections, training, and any incidents or near misses related to scaffolding work. Then step 15 is review and reflect. Periodically conduct reviews of the risk assessment process itself to identify areas for improvement. A well-executed risk assessment in scaffolding works is an ongoing and dynamic process that ensures safety on the construction site and contributes to the successful completion of projects. It is important to involve all stakeholders in this process to enhance safety and minimize risks. Next is assessing the risk. How we assess the risk? For each identified hazard, assess the risk associated with it. Consider the likelihood and severity of potential accidents or incidents. We can use a risk matrix. What is risk matrix? I'll tell you later. So we can use a risk matrix or a similar tool to assign risk levels. This calculation can be a qualitative or quantitative or both if practicable. It is advised that the occupational risk assessment is calculated qualitatively but without excluding other forms of similar competence. According to the risk assessment methodology, each activity is broken down to tasks. It considers the hazards associated with each task and assess the risk by assessing the likelihood of an event of a particular severity to occur and multiplies this likelihood with the corresponding severity. The worst case scenario is always considered. The severity is specified qualitatively by setting classification criteria which determine how serious the impact of a hazard is. Now, let us look at methodologies of risk analysis. There are three methods that we can adopt for risk analysis. What are these three? Number one, qualitative analysis. Number two, semi-quantitative analysis. And number three, quantitative analysis. Let us discuss first qualitative analysis. A qualitative analysis uses words to describe the magnitude of potential severity and the probability that those severity will occur. These scales can be adapted or adjusted to suit the circumstances, and different descriptions may be used for different risks. This method uses expert knowledge and experience to determine likelihood and severity category. Next is semi-quantitative analysis. In semi-quantitative analysis, the objective is to produce a more expanded ranking scale than is usually achieved in qualitative analysis, but not to suggest realistic values for risk such as is attempted in quantitative analysis. Next is quantitative analysis. Quantitative analysis uses numerical values rather than the descriptive scales as used in qualitative and semi-quantitative analysis for both severity and probability, using data from a variety of sources such as past accident experience and from scientific research. Severity may be determined by modeling the outcomes of an event or set of events, or by extrapolation from experimental studies or past data. Severity may be expressed in terms of monetary, technical, or human impact criteria, or any of the other criteria. The way in which severity and probability are expressed and the ways in which they are combined to provide a level of risk will vary according to the type of risk and the purpose for which the risk assessment output is to be used. Now, let us move to probability of an occurrence. This value is based on the probability of an event occurring. When you ask the question, how many times has this event happened in the past? Assessing probability is based on worker experience, analysis, or measurement. Probability levels range from most likely to inconceivable. For example, a small spill of bleach from a container when filling a spray bottle is most likely to occur during every shift. Alternatively, a leak of diesel fuel from a secure holding tank may be less probable. Then we move to severity of hazard. Severity can be divided into 5 categories. First, negligible, slight, moderate, high, very high. So these are the 5 categories or 5 scales of the severity of the hazard. Severity is based upon an increasing level of severity to an individual's health, environment, or to property. Then risk assessment. Risk can be presented in variety of ways to communicate the result of analysis to make decisions on risk control. For risk analysis that uses likelihood and severity in qualitative method, presenting result in a risk matrix is a very effective way of communicating the distribution of the risk throughout a plant and area in workplace. Risk can be calculated using the formula relative risk R is equal to P into S. Here P is the probability and S is the severity. Severity is rated into 5 levels as shown here in the table 1. So the rating of severity is rating severity. First, let us see negligible. What is the description of the severity? It's a trivial minor first aid treatment and worker may be back to the work same day. Then slight, it is explained as minor wounds, first aid treatment may be given. The worker may be back to work within 3 days from the incident. Then moderate severity, first aid treatment is required. Hospital treatment may also require. Then worker may be back to the work after 3 days from the incident, but no operation is required. Then high severity, it is explained as hospital treatment is required, operation is required, worker will be back to work after 60 days from the incident, or requirement for changing post due to injury. Means the worker has to be assigned some other work because of that injury. Then very high severity, then in that case the change of work, and if the highest level is there, then there will be death and casualty. The assessment of the likelihood or probability of a risk is made by using the information which is given here in table 2. The ratings are from very unlikely to very likely, and their likelihood are explained in this table as: for very unlikely, this is impossible or almost impossible to happen. Unlikely event, the likelihood is very low. Possible, it is possible to happen. Then likely, it is very likely to happen. And very likely means that it is almost certain that it will happen. Then rating risk summary. Here the table 3 gives you the risk matrix which incorporates the criteria for assessing the severity and the likelihood, and is an effective tool for assessing and presenting the risk that can be understood at all levels. What does it give? Here you see the 3 columns basically. First is assessment, then second is risk level, and third is the rating, means the quantification. So if we go for the first assessment, means the acceptable risk, no additional safety measures required, then associated risk level is negligible, and quantification is 1, rating is 1. Then for the next assessment, the risk may be acceptable, no additional safety measures required, but a more close supervision and safety measures implementation might be required. The risk will be qualified as slight risk and the rating is 2. The next is not acceptable risk. Action is required, measures should be fully implemented within a month, then the risk level is moderate and the rating is 3. The next is not acceptable risk, action is required, measures should be fully implemented within a week, then risk category is high and the rating is 4. Then final one, risk is not acceptable, action is required, work must be stopped immediately, measures should be fully implemented immediately, the risk category is very high and the risk rating is 5. Then risk qualification. So based on that likelihood and severity, as I told you that risk is likelihood into severity, based on that the table is prepared in which the risk is classified. And the method is that how this is prepared is that if you look at that likelihood in that vertical column from very unlikely to very likely, severity from in a horizontal row negligible to very high. So ratings associated with each severity and each likelihood. Then when you move from vertical column to horizontal rows, where a vertical column and horizontal row meet, then the corresponding rating of that severity and corresponding rating of the likelihood that are multiplied basically, and then you get the risk. For example, for very unlikely, likelihood and negligible severity, ratings are 1 and 1, so 1 into 1 is 1. So here you see in the column against very unlikely, row against one very unlikely, and that column in negligible, 1 number is there. Whereas if you move to that very unlikely likelihood but moderate severity, with moderate severity the rating is 3, the rating of very unlikely likelihood is 1, so here 1 into 3 is 3. So that way this matrix is prepared. And here you see some color coding also, that the green color is the safer things, acceptable things, low risk things. The red color means high risk, basically not acceptable. Such conditions at site are not acceptable. Risk matrix. So to use the risk matrix, first we find the severity column that best describes the outcome of the risk. Then we follow the probability row or likelihood row to find the description that best suits the probability that the severity will occur. The risk level is given in the box where the row and column meet. The relative risk value can be used to prioritize necessary actions to effectively manage workplace hazards. Here you see the risk matrix. Here the three things are there basically which play the role in making this risk matrix. One is probability or the likelihood, that is there on the left top corner. Then risk rating is given there. Then second is severity. So severity into probability or likelihood give you the risk, as I explained in the last slide. And here by the same way this is prepared, and I told you that the color coding basically defines that safer things and the risky things. Here the boxes in green are the safer events basically where the risk associated is low. The yellow one more risky and the red one is the highest risk. So here based on that, if we see at risk and risk level and the actions basically, so in that risk rating 1 to 6, the risk level is low risk. Here it may be acceptable, but review task to see if risk can be reduced further. In second risk rating 8 to 12, medium type of risk exists basically. Here tasks should be undertaken with appropriate management authorization after consultation with specialist personnel, because a considerable risk exists. Then third one is the highest risk basically, or the high risk. Here the risk rating ranges from 15 to 25. Here task must not proceed. It should be redefined or further control measures put in place to reduce the risk. Then only we can move further. Now after explaining that risk matrix, now we move to safety measures evaluation. Completing a risk assessment with safety measures proposed, it is expected that the residual risk is trivial or minor. If this is not the case, then further measures are proposed. Safety measures re-evaluation or revision. The final stage of risk assessment is about re-evaluating and revising the assessment depending on the nature of hazards and the various changes in the method statement. Now, control. What is control? And what are the control measures that may be taken for reducing the risk? Control can be defined as the control is the elimination or inactivation of hazard in a manner such that the hazard does not pose a risk to workers who have to enter into an area or work on equipment in the course of scheduled work. Hazards should be controlled at their source where the problem is created. The closer a control to the source of the hazard is, the better. This method is often referred to as applying engineering controls. If this does not work, hazards can often be controlled along the path to workers between the source and the worker. This method can be referred to as applying administrative control. If this is not possible, hazards must be controlled at the level of the worker through the use of personal protective equipment, although this is the least desirable control. So here, this way we see that we can control the hazard first at source, then between path, and then third at the level of the worker, which is the least desired way basically. So How to select a suitable control? Evaluating and selecting short and long-term controls, implementing short-term measures to protect workers until permanent controls can be put in place, and implementing long-term controls when reasonably practical. For example, suppose a noise hazard is identified. Short-term control might require workers to use hearing protection. Long-term permanent controls might remove or isolate the noise source. What are different types of control? First is elimination. Getting rid of a hazardous job, tool, process, machine or substance is perhaps the best way of protect workers. For example, a salvage firm might decide to stop buying and cutting up scrapped bulk fuel tanks due to explosion hazard. Then next is substitution. Sometimes doing the same work in a less hazardous way is possible. For example, a hazardous chemical can be replaced with a less hazardous one. Controls must protect workers from any new hazards that are created. The next is engineering control. What is this? Redesign. Means jobs and processes can be reworked to make them safer if they are hazardous at this point of time. For example, containers can be made easier to hold and lift. Next is automation. Dangerous processes can be automated or mechanized. For example, computer-controlled robots can handle spot welding operations in a car plant. Care must be taken to protect workers from robotic hazards. The next is barriers. A hazard can be blocked before it reaches workers. For example, special curtains can prevent eye injuries from welding arc radiation. Proper equipment guarding will protect workers from contacting moving parts. The next is absorption. Baffles can block or absorb noise. Lockout systems can isolate energy sources during repair and maintenance. Usually, the further a control keeps a hazard away from worker, the more effective it is. Then is dilution. Some hazards can be diluted or dissipated. For example, ventilation systems can dilute toxic gases before they reach operators. Then next is isolation. If a hazard cannot be eliminated or replaced, it can sometimes be isolated, contained or otherwise kept away from workers. For example, an insulated and air-conditioned control room can protect operators from a toxic chemical. Then, what are administrative controls? Administrative controls involves safe work procedure. Workers can be required to use standardized safety practices. The employer is expected to ensure that workers follow these practices. Work procedures must be periodically reviewed with workers and updated. Then next is supervision and training. Initial training on safe work procedures and refresher training should be offered. Appropriate supervision to assist workers in identifying possible hazards and evaluating work procedures. Job rotations and other procedures can reduce the time that workers are exposed to a hazard. For example, workers can be rotated through jobs requiring repetitive tendon and muscle movement to prevent cumulative trauma injuries. Noisy processes can be scheduled when no one is in the workplace. The next is housekeeping, repair, maintenance program. Housekeeping includes cleaning, waste disposal, spill cleanup. Tools, equipment and machinery are less likely to cause injury if they are kept clean and well maintained. The next important thing is hygiene. Hygiene practices can reduce the risk of toxic materials being absorbed by workers or carried home to their families. Street clothing should be kept in separate lockers to avoid being contaminated by work clothing. Eating areas must be segregated from toxic hazards. Eating should be forbidden in toxic workplace. Where applicable, workers should be required to shower and change clothes at the end of shift. Then, how we determine the control measures. Mitigating risk in scaffolding works require a combination of control measures to ensure the safety of workers and the success of construction projects. These measures may include proper training and certification for scaffold erection and use, regular inspection and maintenance of scaffolding, use of appropriate personal protective equipment, guardrails and toe boards, fall arrest systems, secure anchorage point for fall protection systems, weather monitoring and appropriate measures for adverse conditions. Then finally, safe access and egress. Then training and certification. Provide comprehensive training to all personnel involved in scaffolding works. This includes both theoretical and practical training. Ensure that workers are certified and competent in scaffold erection, use and dismantling. Then regular inspections. Conduct frequent inspections of scaffolding structures. Daily and weekly inspections are recommended in addition to inspections before each work shift. Inspect for signs of wear and damage, including loose connections, missing components and unstable foundations. Design and engineering. Use scaffolding designs that meet or exceed industry standards and regulations, because if we are following the standards and regulations, then means we are designing a safe scaffolding. Ensure that the design considers factors like load bearing capacity, intended use and environmental conditions. Fall protection system. Install and use appropriate fall protection systems such as guardrails, midrails, toe boards and safety nets to prevent falls from height. Ensure that personal fall arrest systems are available and correctly used when necessary. Access and egress. Provide safe and secure access to scaffolding platforms. Install well-designed stairways, ladders or other access equipment that complies with safety standards. Guardrails and toe boards. Install guardrails along all open sides and ends of scaffolding platform to prevent falls. Use toe boards to contain materials and prevent objects from falling. Scaffold foundations. Ensure that scaffold foundations are stable, level and capable of supporting the intended load. Use base plate, sole board or other appropriate foundation supports. Weather monitoring. Monitor weather conditions and implement measures to address adverse weather such as high wind, rain or snow. Consider temporary suspension of work during severe weather conditions. Scaffold tagging system. Implement a scaffold tagging system to indicate the status of scaffolding, whether it is safe to use, awaiting inspection or out of service. Such type of tags you can use. Clear communication. Establish clear communication among workers, supervisors and safety personnel to relay safety information and procedures. Then training and education. Continuously educate workers about safe work practices and the risk associated with scaffolding. Conduct toolbox talk and safety meetings to reinforce safety awareness. Then personal protective equipment. Ensure that all workers use appropriate personal protective equipment including hard hats, safety glasses, high visibility vests and non-sling footwear. The next is emergency response plan. Develop and communicate a comprehensive emergency response plan that includes procedures for addressing accidents, falls, and other unforeseen events. The next is tool and equipment safety. Ensure that tool and equipment used for scaffolding are well maintained and securely tethered to prevent falls. Then regular maintenance. Establish a routine maintenance schedule for scaffolding components and conduct necessary repairs promptly. The next is documentation. Maintain detailed records of training, inspection, maintenance, and incidents to ensure accountability and compliance with safety standards. Then risk assessment. Continuously assess and reassess risk associated with scaffolding work and make adjustment to control measures if needed. Implementing these control measures collectively and consistently is essential for reducing the risk associated with scaffolding works and maintaining a safe working environment for construction personnel. So this way we discussed about the process of risk assessment, how the risk matrix is prepared, and how various control measures can be adopted to reduce the risk. I hope you must have enjoyed this lecture. Thank you.